Okay. Good evening, folks. Good evening. Maztacular. But hey, look, it could well be worth you staying awake. You could be bitterly disappointed. I'm hoping it's the latter, but if you feel the need to sleep, you should sleep. Sleep is very important. So good evening, folks. I'm kind of hoping that we don't need to go and do the usual audio shenanigans. I have done a little bit of testing to sounds coming through, and voice is hopefully loud enough over the top of things, so we should be set up and ready to go. But as always, feel free to sing out if it's not functioning as expected. I think they should be okay though. This is the first stream in a little while. I've been busy, really busy, and I've also been sick. The last thing you do when you're sick is live stream and have people witness your disgustingness live. It wouldn't have been something nice. So I was as kind of a favor. Anyway, the last stream that we did, I think, was it a reverse engineering one or was it the BIM one? I can't quite remember. Hey Stealth and Jay, thanks for coming along. But either way, I remember saying when we finished that last reverse engineering stream that we were another one that was a little. So that's what we're going to do today, I hope. Anyway, to here so you guys can see me. Hello. Hello. It's a shame that like this whole video streaming thing is one way. It'd be pretty cool. It would be pretty cool if you guys could show your faces at the same time. I mean, I like the idea of the Hangouts thing so people can see each other's faces, but that hasn't worked from what I can tell. Virgo MG, hey man, how are you? Thanks for coming along, buddy. So, anyway, as usual, the backing track is from Guy Baroni. I say Baroni, I think it's Baroni and not Barone. I love this guy's music, and it's a really cruisy backing track to all of the stuff that I'm live streaming, and with his permission I am continuing to use his music. So many thanks to Guy. You guys should seriously get onto this dude's SoundCloud. He has some amazing stuff going. So here's the link. I should probably stash it in the notes somewhere, shouldn't I? WebEx at Wolf? I don't think so, man. No way. Not on your life. Anyway, so what I'm going to do is quickly pimp the whole Patreon thing. There are a bunch of people already supporting me on here, and it's really wonderful, and I'm very, very flattered and grateful. But this is the Patreon page. If you feel like supporting me, don't feel obliged. It is certainly not something that I want to force people to do, but if you feel like it, then great. Okay, so as you know, I tend to chow down on some stuff while I'm streaming, and usually it's a combination of dark chocolate and green tea. This is tonight's dark chocolate. We're back to the Lindt 90%. Big fan of this, because it's the kind of chocolate that when you've had just one or two slices, you really don't feel like it. Simeon, you're back as well, mate. Great to see you. Thanks for joining in. Chad, you're in on YouTube as you usually are, I see, which is awesome. So thanks very much, mate. Always a pleasure having you on board. You're just in time, commenting while I'm cracking open the chocolate. So here we go. It's the goods. Oh, so good. So the good thing about this stuff is you have a little bit and you're done. It's not too sugary. Really, really good. Highly recommend that. Pardon me chewing over the top of the microphone, but you know, my mum did teach me to not speak and eat at the same time, but that was a long time ago. Anyway, don't show this to your children. Here we got Borja. Borja's on as well, and so is Loanis. I am not familiar with your name, maybe a new watcher. Wonderful to have you along as well. Thank you for joining in on all of the platforms that you decide to join in on. So that's the chocolate. Highly recommend that. It's really good. good hacking chocolate, in my humble opinion. And so the other thing, green tea. Now, I have been getting into the Gyokuro, which I usually have, but tonight I decided to opt for the Dongding Oolong. And I tell you what, it's definitely one of the best oolongs that I've tasted. It's not sort of an overpowering flavor. It's really quite smooth and soft. If you're into an oolong, and have a bit of dark chocolate with it, it's seriously good. 72% cocoa, garner, peppermint. Yeah, you know, I don't mind the flavor of that, but it's still just a little bit too sugary for me, so I've kind of steered clear. I am a sucker for a good peppermint chocolate, I have to say. So yeah, I'm going to avoid that. Ah, Stealth's got the dark chocolate. Ozjock's in. Oh no. Hey Ozjock. So hopefully Ozjock is sitting there having his tea while watching without spilling it on his laptop, which he was silly enough to do recently. So now he's got a new laptop and is apparently setting it up. Let's hope that he gets through it without spilling another epic amount of tea on a keyboard. Matcha green tea. Yeah, that's a good idea. Barney of the Rubble, good evening. Good evening to you. So that's the tea of choice for this evening. Feel free to have your own. If you have something, and you recommend it, then chime in, because I'm sure everyone out there who's watching this enjoys a bit of a couple of options for future beverages while doing hacking. I said evening chat, not you are. God damn it, I hate that guy. You'll send some tea. That'd be lovely. Love me a bit of tea. Alright, so tonight we are going to do a reverse me. The reverse me that we're doing is this BlueOwl's Quantity Serial Protection Level 2. Now, I haven't done Level 1, but I just stumbled on Level 2. And the reason why I chose it is because it doesn't have any anti-debugging stuff, but the author claims that it's harder than you think. And it's just a classic sort of keygen me. So we need to reverse whatever it is that's going on, but not just patch it. We have to write something that will generate keys. So the assumption here would be that you have to punch in a username and serial number and basically pass the algorithm check. So that's the long and short of it. I don't think there's really anything more to it as far as the rules are concerned. Now I've got the two files here ready to go. Let's see what the README says. So Quantity Serial Protection Level 2. No anti-cracking, no anti-debugging, no encryption. Thank you, because I hate encryption. I'm not a crypto guy. If I see crypto challenges, whether they're in a CTF or in a reverse me, I just skip it because I just can't stand it. I don't enjoy it. There's no packing. Now, I don't mind doing a bit of unpacking, but thankfully it's unpacked. It's a 32-bit application. It was written in assembler, which hopefully will mean that there's a minimal amount of code to wade through. And the author claims it's sort of medium-hard difficulty. So, you know, hopefully we'll get to the bottom of it tonight. If not, maybe we can sort of pause along the way and we'll come back to it for a future stream to finish it off. We'll just see how we go, as per usual. The way I like to do this for those people who haven't played along up until now, much prefer the interaction rather than you guys just sitting there. So if you have any questions, fire a chat comment. I've got it up on the side of my window here, and so when people talk, it does pop up in my face, and I will get to it when I have a logical break, and I'll do my best to answer your question. I think that's one of the best parts of doing this, because the questions you ask make me think, and hopefully the answers help you and other people who are watching learn some stuff. So I have 2 humble packs for whoever wants one, and OJ approves. Ooh, 2 humble packs. Learn some code. Okay, all right. Well, maybe we'll dish those out in the next sort of half an hour, and we'll do it based on questions and interaction and sort of general vibe. So that'd be awesome. Vikrant, hey Vikrant, how are you, buddy? Thanks for coming in as always, much appreciated. And same to you, Parody. And Eric's here too. There you go. Three more regular faces. Lovely seeing you people chime in again. So thanks again to everybody who's on stream. Let's have a quick look at what this binary does. Now, this is a fully patched Windows 10 virtual machine, as of is it build 1803 that was out just a few days ago. So we are doing it on the latest and greatest desktop, but for the sake of a reverse me, it's probably not relevant. I just thought I'd highlight it that we are using, rather than doing something on Windows XP, for example. Backseat driving, welcome. Yes, Parody. Backseat driving. I want all the hints. I want suggestions for how to do things better with IDA. Things like that. That'd be very much welcome. Now we are going to be using IDA. Now I do own a copy of IDA Pro 6 point something. I can't remember. I haven't renewed my subscription of late. But pretty much everything that we're going to do here, you can do with the free version of IDA. So feel free to play along with IDA. Feel free to play along using Binary Ninja. I will try using WinDBG again this time, but last time there was an issue with it, and apparently, according to the people who are working on it over in the Borg HQ, they know that it's an issue with WinDBG inside a virtual machine. So they're on to the problem, but I don't know whether it's been fixed, etc. So, Oxylus, how are you, sir? Or ma'am? Thanks for coming in. Much appreciated. I'll be slow to reply to stuff playing WoW at the same time. Oh, really? That's how exciting these streams are, people. People need to play games at the same time. Not that I blame you. Just woke up on the East Coast. East Coast of Oz. No, you'd be awake for a long time. East Coast of what? East Coast of the US. Maybe. Randall, is that where you are? East Coast of the US? I can't think of it. Yeah, USA. Fantastic. Welcome. Thanks for joining in first thing in the morning. I hope you're having a nutritious breakfast with some green tea. Okay. All right, let's kick this program off and we'll just see what it looks like. Now, if there's anyone out there who has done any reversing of typical crackmes or reverse me's or keygen me's in the past, you'll notice that they all kind of look the same. It's literally an app that contains a couple of boxes for you to fill in and off you go. Now this was downloaded from the old crackmes.de archive that's open on crackmes.cf, and it was earlier in the stream, so you can download that and have a bit of a play. Jazz Vega, is encryption like the volume climb for you and the overhang? Ooh, is that who I think it is? I think it is. Is that you, Regan? Give me a nod if it's you, man. Hey Jay, how are you, buddy? I'm doing really good, thanks for asking. Secfault, you're doing OSCP at the same time. You're hardcore, man. Are you actually in the lab or are you just watching videos? Near lunch in the EU, yeah, I hear you. Yeah, okay, guys. So Jazz Vega, who's watching on YouTube right now, is a climbing buddy of mine. Unfortunately we don't get to climb together as much as I would like, but he's as nerdy as they come and is an absolute top bloke, legend. So thanks for coming in, man. It's really good to have you here. He got all excited when he found out that I do live stream hacking tutorials. So hopefully he'll consider this worthy of his time and come and join in down the track as well. So thanks for coming in, man. Okay, labs indeed. Yeah, well, that's pretty hardcore, man. All right, so we punch in a name and a serial number and hit test, and it's going to say no. Okay, that's a no-brainer. So the aim of this is obviously to come up with a way of generating username and serial combinations, etc. So that's the plan. Oh, stop it, you! I'm so excited. I'm excited too, man. I love doing this stuff, and you'll realize very soon that I'm pretty terrible at it. But collectively, as a group, we seem to manage to come up with the answer, which is always good. Yeah, Jay, that's right. There's multiple J's now. You're excited? Parody, you're a sick man. You're a sick man. I do love you though. Okay, so clearly I'm not going to come up with one. Did you notice in the README though, there are a couple of examples. Let's have a look. BlueOwl. And whatever this is. Okay, so that's what we're looking to do. We are looking to come up with a way of generating serial numbers for this thing. All right, so the first thing I'm going to do is I'm going to fire this up in IDA, and let's start nosing around to see what it is that it's doing. There is going to be some assumed knowledge here, as always. We're not going to be sort of diving straight into the absolute basics of assembly. But I will be covering off a couple of key points for those people who aren't familiar with debugging / poking all of the sort of Windows API internals, etc. So, okay. I remember when I was writing crackmes and keygenmes and reverse me's back in the day, and I'm not going to tell you what username I did that under because that will be revealing a part of my past that I'm not happy to reveal. That most of the stuff that I did when I was writing these things was in assembly. It was Win32, and because I didn't want to go through the horrendous pain of dealing with WinProcs to handle just the general generation of user interface controls, I just used dialog boxes with resources. And that's a really common thing that you'll see in pretty much all of these reverse me's, except for the ones where people really cared about going the sort of full 9 yards and doing the massive windowed GUIs or DirectX related things in C++, blah, blah. But most of them that you'll see that are written in assembly, like this one, will probably just generate a dialog based on an internal resource. Now, if you can see what's on screen here, you'll see that the entry point does two things. It calls get module handle A and passes in null. You can see here, which basically says, give me a handle to the current module. Now, the funny thing is that the handle to the current module is actually just a memory address to where the first, like basically where the PE header is in memory. And I didn't realize that until I started mucking around with Meterpreter and actually trying to emulate the get module handle for a reflectively loaded DLL. Turns out that all you need to do is give it a pointer to the start of the memory location where the PE header is, and everything's fine. And Windows seems to be able to figure things out from there by itself, which is awesome. But if you call get module handle with null as a parameter, that's exactly what you're going to get, is a pointer to an area of memory for the module that you're currently running in. Can you buy me a Yoga C630? No. No, I can't. Sorry. Okay, so once we've got a module handle, we then invoke something called dialog box param A. Now, what I should probably do, dialog box param. So the Windows API has a number of horrible functions in it, and dialog box param is one of them. So for the most part, all this function does is it says, can you please go and create a dialog box and use this resource in this module, and here is the pointer to the function that I want to use for handling callbacks and events and messages and all of that sort of stuff, right? So that's basically it. See you guys, cool stream. Windows internals are just awesome. They're a lot of fun. There's some absolute horrendous stuff in there as well. So the interesting points here really are H instance can be null, but you can pass in the current module handle, which is effectively what this program is going to be doing. You can give it a template name, and the template name can come in the form of a string, or it can come in the form of like a resource identifier. But basically what that is it's a pointer to a resource that's inside the PE file itself that describes what the dialog box needs to look like. So anyway, and then from here we can see this LP dialog func. That's a pointer to the function that I said, which is responsible for handling all the callbacks, events, etc. And this very last parameter here is just an arbitrary value that you can pass in to the callback function when the dialog box is constructed. So hang on, go down here. Lparam. The value to pass to the dialog box in the lparam parameter of the WM init dialog message. So what happens is when the dialog box first spins up, Windows does a bunch of stuff, and then it will call the callback function with this WM init dialog message, and whatever it is that you give it in this parameter, it will pass in as the lparam parameter of that callback function, which we're going to have a look at in just a minute. So let's see what it actually passes in. It's the very last parameter, so null, which is interesting because there is actually a version of this function called dialog box, I believe. Dialog box, which basically does the same as dialog box param, but just doesn't pass in a parameter. But it looks like this is actually defined as a macro. So that's why we actually see dialog box param. So he may not have actually directly called dialog box param. It could have been just the macro expansion at compile time or something similar. Oh, actually, no, he wrote it in assembly. So there is no macro, so to speak, unless he wrote it. So you'll notice that dialog box param A and W both exist. A is for the ASCII version, and W is for wide character strings. So in this case, we can see, based on what's in IDA, he's only using ASCII strings. And given that this cracked me was, when was it? March 2005, everyone was doing things in ASCII back then, so that's not surprising. Okay, so hopefully that describes what's going on, at least as far as the bootstrapping of the program is concerned. What we could do is pull out a resource hacker and look at the dialog template, but that would actually just be a waste of time in this case, because we can see what the dialog looks like when we run it. It looks like that. It's just an easy way of sort of binding controls to IDs and so anyway, close that off. Now, this dialog func is obviously the callback handler for the dialog box itself, and we can see that IDA's picked up on what that is. So let's go and have a look. Now, this could be awful. It could be horribly complex by the looks of it, given that there's only one other function here, this sub. That most of the logic is either going to be in the dialog box function or this function. Just have a quick. Now this graph down here on the bottom left doesn't look that complex, whereas for this one, oh Jesus. Yeah, okay, so that looks ugly as sin, but it's actually not too long, so we can probably wade through that fairly. All right, so let's see what happens. When the dialog box function is passed in, yeah, oh boy, unrolled shit at that. Yeah, that's a good point. Well, it was hand-coded in assembly, so I'm pretty sure that whatever it is it was using didn't have something that was going to unroll the loop, given that it's hand-coded. But yeah, it just looks like a bunch of obfuscated nonsense. But it might just be painful because of the sheer volume of things to do, but maybe the difficulty won't be that high. We shall see. Okay, so dialog box function gets called arg4. So arg4 is going to be, let's go back to our documentation. Now, dialog proc. This is what a dialog proc needs to look like. It needs to take in 4 parameters, a window handle, which is actually the handle to the dialog box itself, an identifier for the message, and then 2 parameters that are passed in alongside the message, and the context of the message is what changes what those things actually happen to contain. Daniel, will this stream be uploaded to your channel? Yes, it absolutely will. I'm using restream.io as I usually do, and that means that it's streaming live to YouTube, Twitch, and Mixer all at the same time. And the video that gets live streamed directly to YouTube will be archived pretty much automatically. So anyway, so we're interested to know what these messages are. Now, when we look at the disassembly, we can see that the first thing that happens is that there's a comparison to arg4. So, and then straight after that, you can see there are other cases where arg4 is checked, right? You'll notice that that's probably going to be checked all over the place. So arg4 is actually the second argument. It's the argv plus 4 bytes, which is the second argument that's been pushed onto the stack effectively. So we know that arg4, we're going to rename this. That's going to be uMessage, right? So you can see, based on the documentation here, uMessage, this one here. It's an integer that defines what the message is that's come in. So when a callback function is invoked by Windows, it gives an identifier of the message and says, hey, this is the thing that's happened and this is basically what you need to handle. So again, when we look back at the documentation for this, you can see this WM init dialog is a message and it's just an identifier and it's hex 110. Okay. So hex 110 just happens to match this. Okay. So we'll put a little comment here saying WM init dialog. so that we know it's checking for the WM init dialog message, and if it matches, it goes here. Now let's just quickly change our options again so that we can see memory addresses. I like to be able to see memory addresses. Only uploaded after he struggles to do it. Yeah, yes. There is some truth to that, unfortunately. Daniel, yeah, no worries, man. If you can't stick around, that's all good. You enjoy your day at work. Hopefully it's not reporting, because I hate reporting. Everybody hates reporting. Ozben, why is it EBP plus 4? So, it's not EBP plus 4. It was EBP plus arg underscore 4. So arg was something that IDA adds to say this is the offset to the arguments based on EBP, and arg4 is basically the first argument, sorry, the second argument, and 4 indicates the size of the argument. So every argument to a 32-bit function is a 32-bit value. So you can see here HDLG is the first parameter, and immediately after that is uMessage. Okay, and then straight after that you'll see arg8, which should be wparam, and then there's another one. You're welcome, no dramas. Jazz Vega, this is a Unix system. Invoking a bit of Jurassic Park. There are no velociraptors here, though. Okay, all right. So basically, at this point, it's saying this is handling WM init dialog. Now, when I highlight this, you'll notice that there are other entries that are highlighted too. Jump block 402146. Now, if we go there, it's probably not going to be doing much. There you go, 146, move EX1 and bail out. So it's probably fair to say that this is the fail all case. This is like the default case, and it's just returning 1 for true. So again, if we go back to the documentation, you can see that it returns an int pointer, which in 32-bit land is a 32-bit value. And the return value, if the function succeeds, the return value is the value of the end result parameter specified in the call to end dialog, used to terminate the dialog box. The function fails because the parameter is invalid, the return value is 0. So people tend to return like true or 1 for a lot of cases when they're just handling messages. It's really not that interesting, it's just something that I thought I would throw in. Ricky33, sadly at school and can't watch the stream. Sorry, man. Maybe next time, hey? Someone's oh man, can you hack my mum's Facebook? Yes, nice troll. No. No. What was that about a buffer pointer? Did I miss a question? J, EBP times arg4, is that a buffer pointer? Yeah, so it is. It basically points to an address on the stack where the value for that argument was passed in. And because it's on the stack, it's 32-bit value. Okay. Multi, thanks for coming in, dude. Ida, what are we? There's always some jerk doing the get system jokes. Had to be you. In fact, I'm surprised that no one's done it before you. It could be because Justin's not here, Pipes isn't here. Who else usually does it? Weigul's not here either. Most of you guys who chime in on the get system jokes aren't around. No OJ stream without get system. Yeah, damn right. Damn right, Eric. Damn right, man. All right. So going back to our disassembly. This is our catch-all case for sure. So let's put I'm just going to call this default. And the reason why I call it default is because in C and C++, there's a default case for a switch statement. And that basically is like the catch-all case for all the other cases that you no longer care about. I was thinking of doing that get system joke. Jay, see, you got to get in quicker, mate. You got to get in quicker. Working on new Mimikatz ones. Yeah, a few people are really chiming in on some Mimikatz jokes lately, so that's great. All right, so let's just quickly duck back up to the top. So here we can see we're checking against 111 for the message. So basically we're saying, okay, if it's not WM init dialog, what is it? So what would be really useful here is to get a list of all the messages that we could have a squiz at. So let's just see. Is there a reference here to all of them? I bet you there isn't. We might have to cheat. Yeah. Dialog box messages. Nope. Nope. All right, so what I usually do in this case is I do things like define, I Google this, WM init dialog. Hopefully someone's got it stashed in a header file somewhere. API. Come on, don't make a liar of me. This always works. It always works except when it doesn't. All right, let's cheat. What we'll do then instead is let's abuse. Actually, let's fire up the interpreter source base because, you know, we all love a bit of interp. Actually, that won't actually work because I don't have interp mapped. So let's create a new project. Don't really care where it goes. And we'll just call it stream. And this is going to be a Visual C++ Win32 project. As long as it's a Windows app, I don't care what else it shoves in, so we'll just hit finish. While that's spinning up, let's look at... Oh, there's quite a bit of chatter tonight, it's great. You said you wrote projects in assembly in the past. Did you use anything like NASM or MASM? I used both, yes. I used FASM as well. Ah, oh, for crying out loud, no. Not again. This is bloody irritating. I'm gonna have to exit. Actually, no. Let me sign in. Let me sign in. Just this is my OPSEC failing on stream, by the way. But I actually don't give a shit at this point. So I just need to sign in. So this is my company address for those people who want to email me on my company address. Let's hope I don't fat finger and no, don't save any passwords, please. Okay, so it is signing me in. What password do you use? I use this password. This is the password that I use for pretty much everything. All right, now the reason why I did that is because Visual Studio comes with some nice ways of viewing stuff. Now, I'm just going to do this. Let's go down here. WM init dialog. You can see that's there, and then we can hit F12 and we can just go straight to it. So there we go. I'll zoom in on this as well. The WM init dialog is 110, and then straight away afterwards we have WM command 111. Okay. So what that means is, if we go back to here, this is handling WM command. Now, those people who don't know what WM command is, we'll dive into this a little bit because that's actually quite useful. Look at WM command message. So when you do things like click on a button or, you know, do a lot of things like maybe a shortcut key or, you know, a bunch of stuff like that. What you're doing behind the scenes is you're putting a message on the Windows message queue, and that message is associated with WM command. So then when that message gets pumped into the callback function for that window, which in this case is a dialog box, you check to see if the message ID is command, and you go, ah, someone's done something interesting like click or hit a button or whatever it happens to be. Okay, so that's what the WM command thing is. And as you can see, the two parameters, wparam in the case of the WM command message has this stuff in it. L.param has something else in it. So you can see, here we go, wparam and L.param. So for example, if someone clicked something in a menu, then the higher of the two words inside wparam is 0. So that's basically identifying that it was a menu button. If it was 1, then it's an accelerator, which basically means it's a shortcut key, right? Then when you mask out the higher word and you just look at the lower word, that will give you the identifier of the control that generated that message, okay? So for example, if you got a W command message that came in and someone had actually gone and clicked like file open in a menu, you would have wparam set to 0 and, sorry, wparam, the high word of it set to 0. The low word would be set to the identifier of the message, the menu item in that dropdown. So it'd be IDM underscore file open, for example. And the final parameter is just 0 because there's nothing associated with a menu click. Similar story with accelerator, like you might go Control O and bind that to exactly the same thing. And so here you get no L.2 and you get exactly the same thing as you would in the menu. Now, when you do things like click a button, it gets a little bit different. So the low word still identifies the control. So like if you had a button like IDOK is a typical button resource identifier, or you might have your own custom button that says show me the stuff. So it might be ID _ show me the stuff, or whatever integer that happens to map to. And then what you get is in L.2, it gives you a reference to the window that control encapsulates. So if you clicked on a button, for example, then this would refer to the window that defines that button, because everything in Windows is a window. And then behind the scenes, there are other things. So for example, this control defined notification code, it could be button up, it could be button down, it could be key up, it could be key down, things like that. So depending on the logic that you're handling inside your program, you might say, I'm only interested when people release the mouse button, for example. So you can handle things in that way. Hopefully that makes sense. Does that make sense? @Wolf. So something unrelated just happened. I checked my junk folder for an email and found an email that said I'd been hacked. They previewed my email address and password. The password was one of my random generated password manager ones, and it belongs to one site that I used years ago. I'm guessing the site is compromised. That's bad news. That is bad news. Sucks to be you, @Wolf. Oxalis, learning from a fellow contributor. Ooh. I'm still trying to guess exactly who that is. I'll figure it out at some point, I'm sure. Okay. Righto. So where do we get to? Let's go back to our disassembly. So what's happening here is it's handling the case where someone's hit a keyboard or a mouse button, blah, 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 that kind of thing. So somewhere in here, it's handling clicking or hitting the OK. In fact, it's not even called OK, is it? What's it called? Test. This test. So when I click test, it's handling this via the WM command handler. Okay, so it's coming in here. 203C, we can jump to that. Where is it? It's this branch here, isn't it? Some sort of 0. Oh no, it's this one here, sorry. Jump here. So this is when the W command handler actually kicks in. And then we're checking to see whether or not, what's it, arg8, that's W-param, isn't it? I should actually call it this, W-param. Okay, so if W-param is 66, so I think there's a bunch of assumptions that are going on here. So if it's 66, then it's not really caring about the high word, because they may all be 0. So maybe there's assumption that it is a button of some kind. And if it is, then we jump down into this branch here. So now what's interesting about this is it goes straight to this function here and it says, nice try, good luck next time. And then bails. Okay, so that means it would be I give up. If I hit I give up, good luck next time, as we can see here, and then it quits. Okay, so let's say this is the quit button. Not quite, the quit button. All right, if it's not the quit button, then it's got to be this other button, right? Oops, you know what I should do? I should get rid of that comment there and actually learn me some stuff. I should put that here, where the W param is actually dead. And then here we can probably guess, based on the fact that this is 66 and this one under here is 65, that this is the test me button, for example. Okay, is that what it's called? Test button. And if it is, so here we check for 0. Does it match? Here we check for non-zero. So if it isn't the test me button, then we go to the default case, which basically returns 1 and nothing happens. So all it's interested in doing in this particular case, when we handle WM command, we're either pressing the quit button or the test me button, and that's all the code really cares about. Still no questions about what's going on so far? Start typing while I have some more chocolate. Okay. Now, I'm going to give you a little bit of history, which hopefully won't be boring. But it might be. No promises. So, years and years ago, when I first got into doing this kind of reverse engineering, there was a tool that I installed on Windows 95. This is how long ago I was doing. Windows 95. The tool was called SoftIce by a company called Numega, and it changed my life when I was told about this thing. I was told about this thing by a guy called Sam Marshall, who runs a security consultancy in Sydney and is a very dear friend of mine. He works for The Missing Link. And he and I were very close friends during university, and he was the one that put me on to SoftIce. And as I said, it changed my life. Now, during the time that I was playing around with SoftIce, I learned a bunch of really interesting things, including Windows internals. There you go, Parody, you were a SoftIce user as well. That's awesome. Regan, stay with me, bro. Next time we go climbing, I'll more than happily dive into this in a bit more detail for you. All right, so SoftIce was actually a kernel debugger that you could use on Windows 95. And once it was installed, it was a kernel driver that you installed. You hit Control-D, and the window basically popped up over the top of Windows, and it was like an old-school DOS-style application. And it was like what we're used to seeing now in classic debuggers, whether it's WinDBD or IDA Pro or whatever it happens to be. You could see registers, you could read memory, you could write memory, you could see code, you could modify code. Back in the day, Windows 95, basically, almost everything was like read, write, X. So you could just modify stuff on the fly. It was great. So one thing that I really loved about SoftIce was how easy it was to script. So you could bind little macros to keys. And one of the macros that I had would allow you to say, set a breakpoint. And then when you hit that breakpoint, you hit a shortcut key, and it would take you to the exact point where that function was called. So you didn't just land at the prologue to the function, it would take you back to where the function was called to the point immediately after. So you didn't have to wade through, for example, all of the nasty Windows API proxies and stubs that are all over the place. You could jump straight back into the process that you're interested in without having to sort of constantly step back out of a massive call stack. So that was cool. So I would get so used to cheating at these things. I would look at something like this application and go, right, it's a dialog box. And when I hit test, it's probably going to do one thing. It's either going to call get dialog item text, or it's going to call get window text. So if we go back over here, I'm going to show you. Get dialog item text is one, and then get window text isn't actually in here, but it's effectively the same thing for a generic edit control. All right. So get dialog item text does exactly what it says on the tin. You give it a handle to the dialog. You give it the identifier of the control you want to get the text out of. You give it a buffer where you want the text to be copied to, and you give it the size of the buffer so that you don't end up doing stupid stuff like overflowing your own buffers, because that would be bad, right? So what I would do is I would set a breakpoint on get DLG item text, or I would set a breakpoint on get window text, and then just run the app and hit go. So I'd type in my name and I'd type in the serial number and I'd hit go. And then as soon as get dialog item text, for example, was invoked, SoftIce would kick in. And there it was. And you'd hit this shortcut key and it would take you straight to the point, like what we're seeing here. It would land, say, on this line, and you could see exactly where that function was called. Now, what was great about that is from there, you can just look backwards and you can see where buffers are, and you can get a very clear idea of where things are in memory. And then you can start tracing exactly what the program's doing with the input that you've given it. And from there, start to, unwind things and try and figure out what it is that you need to do to make it all work. So that's basically how I did it in the old days. I had SoftIce running. I would set breakpoints on Windows API functions, run my apps, punch in some data, hit go, have soft ice pop up in my face, hit my macro, and then I would just start debugging and reading. It was a wonderful time of life, and it's what kept me sane as I was going through university in the late 90s. So, hat tip to all my fellow old fellas who know what I'm talking about, and yeah, those people who have never experienced that before, man, you're missing out. It was a time to be alive, let me tell you. Oh, so good. Only 90s kids remember. Yeah, look, I'm pretty sure that Soft Ice was bought by another company not long after, like, early 2000s. And yeah, it was, I don't know what happened to it. Hey, maybe we should have a history lesson on that one day and go and dive into it and see if we can get a VM up with Windows 95 and a copy of Soft Ice. That'd be awesome. Anyway, I'm digressing. It is 8:45. We should probably progress. So what we can see here is there are two calls to get dialog item text A, so the ASCII version. And clearly what this is doing, we probably don't need to be geniuses to figure this out, but we are getting the dialog item text. We're getting the text out of the two edit controls that are on screen here, and we're storing them in buffers. So string is one of them, and dword blah 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 is the other. Okay. From here we can see we're starting to do sort of some operations on the information that came in, and doing some other shenanigans. It looks like there's a loop involved here as well, which we will go through the pain of reversing in just a minute. So clearly this is the most interesting thing. Let's change the color of this node to something slightly off-putting. There we go. So we know that this is the node where the things actually start to get interesting. Okay. Now we don't know which one of these is which. We can make the assumption that people read things in the order at which they appear on screen. So maybe this string element here is actually the username, and this dword here, which is just a pointer to a buffer, is where the password will go. But really the only way to validate that is to debug it. Now, as I said, I'm not going to go through and use WinDBG because there were issues with it in the past. So I'm just going to fire it up here. So let's add a breakpoint. We're going to use a local Win32 debugger, and I'm just going to hit go. Yeah, we know. All right, so I'm going to say the colonial, and my serial is AABBCCDD, and we're going to hit test. And here we are. Excuse me. So we can see that we have broken immediately after this call to get dialog item text. And somewhere in memory now is a thing. It's going to be one of those two things that we've punched in. I'm guessing it's going to be the name. Now, string, as we can see here, we should be able to look at this in a new hex window. And it's blank. I don't think it's actually blank. Ah, look at that. 54, 68, 65, 43. Okay, so there's a mixture of case there. We can see upper, lower, lower, upper, lower, lower, lower. So that's the colonial. So this is definitely the, I'll put input username so that we know it was inputted, because chances are it's going to munge the username as part of its serial generation routine. So then here it's probably fair to say that this is going to be the input serial. Is it a serial number? Yeah, serial number. Okay. Now let's just... okay. What are the shortcut keys again? Step into, step over. Okay. Step over, step over, step over, step over. Now at this point, I just want to look at this in a new hex window. We can see this is blank. And if we step over again, it shouldn't be blank. Clearly it is. I think I'm doing something wrong. Someone tell me what I'm doing wrong. That's pushing the offset of this thing. We can see, there you go, look, 4, see how it says 4141 4242? So that's AABB. So we know that that's definitely containing the serial number as well. Was a godsend breaking stuff. What's the support having a second monitor attached? Which, yeah, that's so true. I remember those days as well. Okay, so you can see that the serial number and the username are now stored somewhere in the processor's memory. Right now, we don't really give a shit about it, but it looks like they're just global memory locations based on the fact that, what have we got? Input serial is, yeah, so that's in the data section. No biggie. So it's a global variable. The issue is you aren't drinking your well. Is that better? You're probably right. Let's say you're probably. Okay. Now let's have a look at what's going on here. So we take we hit, what is it, F8. So EAX, which as we know is the accumulator. The accumulator register. Fancy name for a very fast mathy thing. EAX has the first 4 bytes of, sorry, the first 4 bytes of what we've entered. Then what do we do here? We move this global value here, which is the next 4 bytes. See that? 4343, 4444. The next 4 bytes into EBX. And sub that. So basically we're taking the whole 8 characters that we've punched in the serial number, and we are subtracting capital A from everything, right? Capital A, which basically means we're trying to get, by the looks of it, an index of every single one of those characters. Okay? One would assume that at this point it's expecting to have 8 characters for every serial number. Let's have a look. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There you go. So it's expecting an 8 character serial number every time. That's good to know. Let's document that. Let's just put that in. Yeah, expecting 8 characters for serial. Okay. Not enough grr. Grr. Am I doing it right now? Grr. Tea's so good. Okay, so we're converting every single one of these things, this input serial, into an offset from capitals. So if it was capital A, we'll end up with 0. If it's capital B, we'll end up with 1. If it's capital C, we'll end up with 2, etc., etc. It may actually be fair at this point also to assume that it's expecting to have capitals the whole time. Now, both of these are capitals. So maybe I should document this assumption as well. Expecting 8 characters for serial probably should be uppercase. Just so that we know. Alright, let's go hit. And when you're in IDA, make sure you make a habit of pressing Control W, because that saves the database. And then if things crash, you don't lose your annotations. Because this does crash a bit. I was having a chat about this with my friend Drone. He kept saying how he's infuriated by the fact that he hasn't got the muscle memory yet in IDA to constantly save, and he ends up losing changes. That's never a good thing. Nobody likes that. All right, so EBX. We can see EBX up here. Now, as I said, now what is it that I had? I had, I put AA and BB in the first 4 bytes of my serial, and then CC and DD. Yeah, so EAX is, you can see the 2 zeros at the start there. That's the 2 A's. And there's the 2 B's. And then in BX, you got the 2 C's and the 2 D's. Right? So what is this doing here? It's going shift EBX left by 4. So we're going like a nibble across. Okay. So we should see EBX, this should be 30302020 after this instruction. There it is, 30302020. So we've shifted everything in EBX across by a nibble, half a byte. Then we OR these two things together. Now this is interesting. So EAX will become 31312020. There it is. Now we stash this in a different memory location. Let's rename this one input input serial B I'm going to rename this input serial A so that we can refer to the sort of two 4-byte blocks of the input serial. Now this looks like it's done this very simple calculation over the serial number, and it's stashing this in what appears to be yet another global variable, which at the moment is immediately after serial number. You can see here this DB0. Excuse me. So that's the null terminator for the text that's come in, and then we've got this, what looks to be some kind of checksum perhaps, that happens immediately afterwards. So I'm just going to go calculated checksum. All right, and save. All right, so now what are we going to do? We've got this calculated checksum, and then we read out the, basically we get a pointer to the username stashed in ESI. So there you go, input username. And it looks like we're going to start doing some magic with it. I'm out, but thanks for the stream. Looking forward to finish watching recording tomorrow. Cool, thanks Ben. Appreciate that, dude. Have a good one. Yeah, okay, so we're basically going to go and do something over the top of the username to see whether or not we've done enough correct stuff to move to the next stage of serial number validation. Right, okay, so what happens here? EDX is currently set to 8, which just happens to be the length of the string. So how is it that that's the case? Now, why would EDX already be set to 8 at this point? Is that a fluke? Shouldn't be. Sin, how you going, man? Nice to see you tag along again, mate. Yeah, EDX. Why is EDX already set 8? I mean, at the end of the day, it doesn't matter because it's setting it to 0 now, but it's just interesting. I can't see where EDX is set. It just happens to be set to 8. Maybe that's just a fluke. So yeah, anyway, we're subbing EDX from EDX, which means we're going to end up with EDX set to 0. So it doesn't really matter how it came to be. It's probably just an overhang from a previous function call. All right, so what are we doing now? Lot SB. Who knows what lot SB does? Any ideas? I don't actually know why it's used in this case. See what it says. It loads a byte, word, or double word from the source operand into AL, AX, or EAX register respectively. Okay, that makes perfect sense. So lot SB basically says from ESI load into EAX a single byte. So you'll see 54 is the first byte of the username, okay, which is a capital T, right? For those people who don't know, capital T is, there you go, hex 54. All right. So we can see that we have load a signed byte 54 from ESI, and we increment ESI. So ESI was 401004, and now it's been incremented by 1. Load string by byte. Thank you, Max. Perfect. Load Sound Blaster. Sound Blaster, man, what a blast from the past. Try Redair 2. Hey, look, one day I will invest a bit of time in Redair 2. It's just currently not on the radar. Pun intended. Just not quite on the radar for me yet. When I'm doing my live streams, I'm sticking with tools that I know for the most part. I just want to sort of share with people how I use them. But down the track, you know, maybe you can do a stream with me and we can tag team it. You can share some of your Nestleized spoilage with me. All right, so we load a single byte. And here you can see the next thing we do is or AL, which is interesting, right? Because that should pretty much do nothing, as we can see. Doing or AL really only affects the flags. So all that's going to be doing is like if it's 0 or it's negative, then it's going to change things like the sign or the 0 flags. So here you can see we go or AL jump 0 to 4020D7, which is down here. So this is an indication that it's reading out a byte and it's checking to see if that byte is null. Pardon me. Sin R2 is really good. I have no doubt about that, and I've seen some videos on it, and it's super impressive what it can do. I just haven't dived into it, and it would be like watching a total moron fumble his way through an app he's never seen before. So, you know, if that's appealing to you guys, then I'm happy to do it on stream because, you know, that's what we do. But at this point, I'm working through stuff that I am at least semi-familiar with. Looking a bit ahead, but EDX comes back in the following checksum. Yeah, it does indeed. But at the time that this loop actually starts, EDX basically just gets set to 0. OJ, if you want to try Redare, try it with Cutter. Makes it much easier to jump into. Okay, all right, Sin. I'll have a look at that. I'll stick it on the list of things to do. Serializing me. God, I tell you what, on my screen, your name, serializing, is like a bright green, and the contrast on the background is impossible to read. So I actually have to highlight your name so that it's no longer bright green so I can read it. The problem with R2 is the debugger function. Oh, okay, the debugger's a bit flaky still. Okay, maybe we can start playing with things like WinXDBG or whatever it is, the open source version of the 64-bit debugger. All right, so basically what we're doing here is we're saying, have we reached the end of the string? So that's what that's checking for. End of the string has been reached. Okay, so let's just get an idea of exactly what this is doing at this point. So if it hasn't reached the end of the string and it's moving the value of 8 into ECX, and it looks like it's going to do this loop here or bailout, depending on the result, right? So let's see what it's doing. Move ECX 8, so ECX is now set to 8. We shift AL right by 1. Okay, so 54. Geez, whatever 54 is in binary, in hexadecimal. So that'll be, what would it be? I don't know. 16. 4 lots of 16. 32. So it'd be 32 plus 16 plus, I don't know. Let's just have a look. So it goes down to 2A. Okay, so we're shifting that one byte right by 1 bit. And then we're saying JB. Jump if, is that jump if below? Is that to do with signing? Sem JB instruction. Can't quite remember what that number. Jump if condition is met. Yeah, no did. Jump short if below. Oh, if the carry flag has been set. Okay. Okay. That's probably sort of saying if it gets down to 0 again. And if it's not, then we XOR EDX with this hard-coded value, which, because we've started with 0, is 8F7B. It is the actual value itself. Then we add another hard-coded value to EDX, and then we byte swap EDX. So that should just result in what? F4 4B 8C58. There you go. So it just does a 4-byte swap. And then loops. Okay, so that's going to do that. Given that ECX is now set to 8, I would assume it's going to do this 8 times. Have a look. Yep, it's done it 8 times because I pressed step over. You can see EDX has been well and truly munged. And now, come back in the top and grab the next byte, which is 68. And then we go again. I'll press F7 this time. There you go. See, I'm F7, I'm looping through. F8, Okay, so we've got the general flow here. You can see what it's doing. It's not doing anything particularly complex. Clearly we've got to go through all of my... was it 8 times the colonial? 1, 2, no, 3 more. 11 bytes. 3606F. And 6E. 69, we've got to be getting close now. 61. 6C. Come on, I'm just watching EAX and I want it to go to null. As soon as it's null, there it is, it's null. Okay, so we know we've reached the terminating null character. What do we got here? Ah, Will's here too. Hey Will, how are you, buddy? Serious question, will you be a referee for me? Yep, absolutely. Will, thanks for coming along, mate. Might want to ask what he would say about you first. Yeah, I didn't say I'd say good stuff. What program is this you're using? The Experiment Z. I am using something called IDA, or IDA, the Interactive Disassembler. This is the Pro version, but the features that we're using are not specific to Pro, so you can grab an open source, sorry, not an open source, a free copy and play along if you wanted to. Okay, so we finally made it to this location. All right, so now we're pulling out the previously checked checksum. We've stored that in EAX, so that's the 31312020. We push all of the registers onto the stack. Really? Now we know that EDX contains the whatever it was that was calculated before. So 5734090, that value there. It looks like to me that EAX and EDX are effectively the only things that are of interest here. So then once we've called that, we then call this one sub, which we know looks like dog's breakfast. And then the result of that, obviously there's a bunch of stuff that's going on inside that function, munging the stack where all of those register values happen to be. And then once that's been called, which I'm just going to step over for now, we can see that all of these values are very, very different. We're going to exchange EAX with ESP plus var10. So somewhere on the stack, I would assume it's on the stack, based on the fact that we're actually offsetting from the current stack pointer. Somewhere on the stack there is a result